Well, we are almost finished with the right half of the cladogram, the Ornithischia. Recall that these are the dinosaurs that have the so-called bird hips. The ischium and the pubis are aligned together, pointing backwards. And we covered the Thyreophora, the shield bearers. We covered the Marginocephalians, the dinosaurs with extra bony projections off the back of their skull. And what we're left with are the ornithopods. Now, the name literally means bird feet. So if you look at this, they are the bird-hipped and bird-footed dinosaurs, but as I keep reiterating, they are not the dinosaurs that ultimately become ancestors to the birds. So the name is kind of confusing. Well, what are they? They are all herbivorous. They're a group that lived through the heyday of dinosaurs. So basically all of the Jurassic and all of the Cretaceous. In fact, they are among the group that dominates in the latest Cretaceous as the big mass extinction for these dinosaurs come along. And the name is unusual because the foot bones give them their name, but what is particularly important about them are the features of the skull and the maxillary. Now, the maxillary, that's the jawbone that holds your upper tooth row. We all have a maxillary. If we look at some of these features here, notice that they have the maxillary, there's that upper tooth row, and then they have a premaxillary. Remember that these ornithischians have this bone in front of the maxillary, so it's called the premaxillary. And notice that the teeth implanted in it are at lower level. If you drew a planar line right there, they are lower than the teeth in the maxillary. Besides that, the maxillary has a lot of different sort of props and struts and basically bony projections that stick out from it laterally. And what this does is it makes the teeth sort of inset or sunk in, and it creates a large cheek pouch. So these organisms had to process lots and lots of vegetative chow, and so they had, they filled their cheeks with it. If you've ever seen pictures of chipmunks stuffing their cheeks with their foods, that's what I would imagine a lot of these dinosaurs look like. And then what I also think very interesting is how their lower jaw is connected to the skull. So the jaw joint where our dentary, our lower jawbone connects to our head, it hinges up near our ear above both of our tooth rows, but these dinosaurs hinge it way down here. Notice the hinge is lower even than the tooth row in the dentary. Interesting things. Here's a more detailed ornithopod cladogram. And so again, everything above that node is an ornithopod, and we have two sort of primitive or early groups, the heterodontosaurids and the hypsilophodontids. I've put X's over the two that we're not going to cover just because they're kind of minor and not important here. And then the two groups left up here, the most derived dinosaurs in this group, the iguanodontids and the hadrosaurids. So let's look first at the heterodontosaurids. The name literally means hetero, different, dont, tooth, the different toothed lizards. They are an early group. They're in the earliest group, in fact, from the early Jurassic, and they're only found in Africa. Look at this length here, 1 to 2 meters. Now remember, that's from the tip of the nose to the tip of the tail. So this would be like holding a cat with a tail twice the length of a regular cat, a small little dinosaur. And they are noted by having these chisel-shaped cheek teeth, which is another type of tooth that is adapted towards snipping and processing vegetation, different than the leaf teeth we've seen before. But where they get the name comes from the teeth up here in the pre-maxillary, and then at the front end of the dentary, these long, sharp canines. Now, for a long time, it was thought that these were evidence that these were carnivores, but we don't think that's true anymore. So we think that these big, long projections were more like tusks for display among the males, defensive purposes, that kind of thing, because the rest of the organism's tooth structure suggests herbivory. Was there some sort of sexual dimorphism where males had longer tusks like boars today? But we don't know. We don't know. Looking at these, they are clearly a bipedal group. Long hind limbs, short forelimbs. They had a dental battery, meaning multiple replacements of these teeth. And you can see here a couple pictures of a fresh tooth with the chisel shape and then the leafy projections, and then a worn tooth which would get shed and replaced by the next one up like that. They do some interesting things with their skeleton as well. They have fused the tibia and fibula together. If you've ever eaten chicken wings and things like that, you've seen this fusing that goes on in birds. But tibia and fibula is unusual for fusing in dinosaurs. They also fuse a lot of the tarsals or the ankle bones, and we think that this is some adaptation for swift movement, fast running. Don't know. Here's an artist's representation of two males squaring off, flaring those big tusks at each other. Perhaps they're fighting for females or territory or some other resource. An interesting group. The other primitive ornithopod are the hypsilophodontids. And we've seen hypsilophodontids before when we talked about Dinosaur Cove in Australia. And you can see here they have a worldwide distribution. They're a later group, so instead of being the early Jurassic, these are sort of the replacements of those. And they linger up to the late Cretaceous worldwide. And they have a great fossil record. We have many skeletons, plus eggs, nests, all that good stuff. If we look closer at the face, you see that they do not have the prominent tusk canines like the heterodontosaurs. Interestingly enough, they don't have as much of a set of projections on the face to make a bigger cheek pouch. Instead, they have a very jointed skull, which we think perhaps allowed them to flex it to create or allow for more room to stuff their face, literally. Same sort of chiseled shaped leafy cheek teeth. Notice here that they're not as prominently sort of stitched together or locked together like the dental battery of the heterodontosaurs, but close. Artist representation of these, and here it's probably very fanciful with the blue faces and orange bills and stripy patterned bodies, but you get the picture. The stance is right. That's it. Now, the dominant families of the ornithopods are the two up here, iguanodontids and especially the hadrosaurids. So let's look at the iguanodontids first. They're another group that spans the Jurassic, but this time they only linger to the early Cretaceous. And as you can see there, they can be quite large, 10 meters. That's, almost 40 feet of length for these things. Can be huge. Interestingly, their thumb, so digit 1 of their hand, it's all fused up. It's not all flexible and movable like our thumb. It's just a sharp, pointy spike. Okay. The premaxillary and predentary are longer and more extended than the other things we've already covered today, but they are toothless. And so they have a large toothless beak, and we're going to see that the hadrosaurs do this as well. Now this dinosaur you're looking at here, Ouranosaurus, is a particularly large one, and you can see a couple of artists' representations of these things in both the bipedal orientation and then the quadrupedal orientation that is suggested by the track data that we have for these things. The genus Iguanodon, of course, is very famous. If you think back to when we discussed the history of dinosaurs, we talked about the Mantels Gideon and Mary and them finding teeth of iguanodon. So iguanodon was the name that was given to this thing. Here it is in all its glory. The forelimbs are roughly about the same length as the hind limbs, so probably had a lot of quadrupedal movement, but some bipedal movement. It has there, as you see, the thumb spike, and then what you can't see is that, maybe you can sort of see it here, the digit 5, the pinky, is longer and thinner, so there's some weird modifications of the hands. Huge dental batteries, lots and lots of teeth, and this bigger, longer face, but remember, the toothless beak is here. Now, they are largely replaced in the middle to latest Cretaceous by the hadrosaurids, which do this same thing. They can be just as long as the iguanodontids. They have the toothless premax and predentary, but it gets larger and more flared out and creates this duck-billed effect. So these are the duck-billed dinosaurs, and they have huge dental batteries, many, many replacements of these things. What you're looking at in the lower picture here is a photograph of the interlocking teeth of these dental batteries. They have webbed hands and feet. We know this from the tracks and trails, which again clearly indicates an aquatic lifestyle or a semi-aquatic lifestyle. Basically, they lived near ready sources of water. And then what we find, because these things were so abundant, especially this Edmontosaurus here, is that we have several mummies that have been found with these things, which have preserved soft tissue, preserved organs, preserved other sort of bodily aspects besides just the skeletons, including their diets of last meals. So clearly they ate lots of pine trees, but a whole bunch of other things as well. The skeletons themselves, from the neck down, boy, a lot of these hadrosaurs look exactly the same. The variation comes with the skulls, which allows us then to divide these things up into two different subfamilies, the Hadrosaurinae and the Lambeosaurinae, and you see the different descriptions of these things. Basically, the Lambeosaurs have huge nasal projections off the back of their heads, and then the hadrosaurs have projections, smaller projections, on the front side of their heads. Here's an artist's representation of several hadrosaurs in their environment, standing bipedally here, walking around quadrupedally here. You see just a little side image of the vertebrae and then the ossified tendons holding them together. Just an interesting viewpoint. Of course, a picture of an entire skeleton here. And generally, if you want to see dinosaurs in small museums around the United States, you're going to see Edmontosaurus. It generally is so abundant. It's one of the dinosaurs that people can readily find. There are examples in the Geology Museum at Madison, the Milwaukee Public Museum in Milwaukee, Carthage College's little dinosaur museum has some of this. The Burpee Museum in Rockford, Illinois. Of course, the Field Museum in Chicago. You can get a lot of hadrosaurs this way. Just some pictures of the nasal passages in some of these Lambeosaurs, and you can see just huge sections of volume devoted to filling with this sort of nasal passage, sinus cavities throughout these. So perhaps these were great noisemakers, resonating. I've also included the photograph down here where the populations are sort of divided into these ones with long back or upward projecting crests versus shorter backward or looping back crests of perhaps males and females separated. Don't know. And then finally, I like this picture here because here's some poor Lambeosaurus, one of these large ornithopods, but it is being attacked by these smaller, much smaller carnivorous dinosaurs down here. Now, no dinosaur we've talked about yet has had a carnivorous lifestyle. That's because they are all from the completely different group of dinosaurs with saurischian hips. So this makes it puts sort of a punctuation mark. We're ending with the ornithischians, with this ornithopod here being attacked by the next group we're going to study, the saurischians. But before we get to the glorious vertebrate carnivores like raptors and T-Rex and Allosaurus, we're going to go through the giant sauropods first. But this ends our discussion of the ornithischians.